Hello, this is Mr. Gieske. We're going to talk about the ambiguous case that comes up when you're trying to solve triangles. Um, I guess we can start with the idea of these unambiguous cases, these four. Um, these emerge from the congruency theorems that you learn in geometry. If you can remember when you learned that, if two triangles have the same three sides, then same side lengths, then the two triangles will be congruent. That's the same thing as saying given three side lengths, you can create one and only one triangle. So that's a pretty easy logical jump if you can make it. The only proviso under the SSS is you just have to avoid the situation where you have, say, one side of like 30, another side of like 6, or sorry, 10, and a third side of 14. This is not going to make a triangle because one of the fundamental principles of a triangle is that the sum of any two sides is greater than the third. So that's the only condition under SSS that you have to meet in order to have a triangle. Okay, the next one is SAS. If you're given three parts of a triangle, that means two sides and an included angle. For example, if you gave 71, 80, 80 and an angle of 48 degrees, you're always going to be able to create a triangle. There's no circumstance under which you can't fill in a side here and then obtain the other angles as well. How to do that requires knowledge of the law of sines or law of cosines, but this will always work every time. ASA, similar to SSS, is a guarantee provided that your two angles don't add up to be more than 180 degrees. So you can't have a situation like this, where you've got 12 here, and then you've got a 100-degree angle here and a 93-degree angle there. It's just not going to work. Obviously, you can't make a triangle. So there's sort of a basic provision that two angles can't take up more than 180. And this means, remember, that the side has to be included between the two angles. So that's crucial. And then finally, if you think about AAS as some given information, that's two angles and a non-included side. Well, if you have the two angles, you can find the third angle. So and then you're going to get ASA. So AAS is a really diminutive, or just a subcase of the ASA case. So the idea here is that if you're given three sides with that provision, two sides and an included angle, two angles and a concluded side with that provision, or any two angles and a side, really, you're going to be able to make one triangle exactly. And there's nothing ambiguous about how to do that. You just need to work the law of sines and cosines, or maybe it's a right triangle and you can use the Pythagorean theorem and subtraction of angles to get the third angle. Now, the case that comes up that is ambiguous is the given information of SSA. That's two sides and a non-included angle. So this situation emerges or falls out in lots of different ways depending on the relative sizes of the given sides and angle. So I'd like to walk through those possibilities with you, and I want you to pay attention to the diagrams I've got here. So in case one, well, first of all, just pay attention to the way I've got this set up. This dotted line is not the side of a triangle. It's just a reference of the horizontal. So I can make this angle A a known quantity. Okay, so angle A is given, and I'm measuring it along this side B, made an angle with this dotted line. Okay, so angle A is given, side B is given, and then side A is given. So side A is opposite angle A. And in this case, I've drawn this vertical height here as marking as length h, not part of the triangle, just for my reference. Because if side A is not long enough to get to the dotted line, which is the place where a third side would go, if it's not long enough to reach that dotted line, then we can't make a triangle. So side H here is a perpendicular, so it's the shortest distance from this vertex down to where we could make another side. And if side A just isn't long enough to do that, then we can't make any triangles. And then over here in red, I specified how long side H is. You can find that out by using the sine of angle A is equal to H over B. So sine A is H over B. Therefore, H is equal to B sine A. So remember, angle A is given and side B is given. And with those two pieces of information, B and angle A, you can find out H and say, okay, is the second side that I'm given longer than H? If it's not, no triangles. And that's what I've got here. A is less than B sine A. Therefore, no triangles exist. That's case 1. Case 2 is the situation where A is exactly the same length as H. Okay, so A is equal to B sine A. In that situation, you've got one right triangle that could exist. Okay, so A is just long enough to reach the dotted line, and you can see the triangle I'm forming is B, A, and then whatever this length is, which I can find out in this case using just some right triangle trigonometry. Case 3. A is long enough to reach this side in two places. Okay, think of side A as like swinging on a pendulum. Okay, it's swinging on a pendulum like this, and it's going to intersect the dotted line in two places, and you can make two triangles in this case. So A is longer than H, okay, but it's not as long as B. So when it swings, it actually intersects the dotted line in two places. And in this case, you make two triangles, and they would look like this. You'd have angle A, side B, side A, all given, all the same. But what's in this triangle, we have a shorter side C. I'm calling that C prime, and this is a longer side C. We have a smaller angle C prime and a larger angle C prime, and then we have these two angles B prime and B. And the special thing about B prime and B is that they are supplementary angles. I guess you can see that that this angle in here, okay, has to be supplementary to this angle right here, because they make a linear pair. And you can see that this little triangle here is an isosceles triangle. So meaning that this angle and the angle that's not marked there are congruent angles. So that means that if this angle here is supplementary to this angle here, and then this angle here is congruent to this one over here, then therefore these two must be supplementary. That helps when you try to solve these triangles. If you have to make two, you can if you find B, you can find B prime, or if you find B prime, you can find B just by knowing that they're supplements. Okay, last case is side A is actually so long that it's longer than side B. So it's definitely longer than H, which isn't marked. Okay, we're going to make a triangle, but when I go to swing side A, I actually swing it past the intersection of where B begins, and I can't make two triangles because then angle A wouldn't be part of the triangle. It would be like over here, and then angle A would be outside of the triangle. So side A is so long that I only can make one triangle. So in that situation, A is longer than B. So let's just review. We have 4 cases that are possible when given SSA. One results in no triangles. A is so short that it can't reach the side that would form the triangle. Side A is just barely long enough to reach. That makes one right triangle. Side A is long enough to reach in 2 places. Okay, so it's longer than H, but not so long that it's going to make case 4. And then case 4 is A is really long and it makes only one triangle. So before you go on to think about solving triangles, the first thing you need to reference is the value of H. Okay, find out the value of H before you try to determine how many triangles there are, because you can see that third side you're basically comparing to H, and all cases. You're saying, is it shorter than h? Is it equal to h? Is it longer than h? And then is it longer than h but shorter than b? So you sort of need to have your wits about you before you figure out which case you're in, and part of that is finding out this height. Okay, so let's look at an example problem here. I'd like to go through with a specific given information. If angle A is 73 degrees and side B is 20 degrees, I'd like you to walk through with me what side A has to be to create each of these cases. So again, we're given a certain angle A and a side length B. Let's see what A has to be to create these four cases. Okay, so the first thing we have to do is to determine the value of h. But let me just draw a nice picture over here. So here's the horizontal from which I draw a 73-degree angle. And I go out a length 20. Okay, so now I need to figure out h. That's going to be a reference for me. So the sine of 73 is equal to h over 20. So therefore h is equal to 20 sine 73. Okay, and I can figure that out on my calculator. 20 sine 73. Quickly just make sure I'm in degree mode, which I am. So I'm not doing 73 radians. And I've got this as 19. H is equal to approximately 19.126. So H is approximately 19.126. Okay, so that's the length h. So if I want to make 0 triangles here, how must side A be? So I'd like to have the picture that looks like this. Here's my horizontal. Here's my 73-degree angle. Here's 20. And I'd like for side A not to reach. Okay, so what we've just said is that A must be less than 20 sine 73. Any number A that's less than that value, roughly 19.126, will result in 0 triangles. So for example, if A equaled 14, I'd have no triangles. Okay. In the second case, I'd like to have a similar picture. Here's my 73-degree angle. Here's my side length 20. And if I make this side exactly equal to h, so if A equals 20 sine 73, I will make one right triangle. Okay, so that has to be exactly 20 sine 73, which is approximately 19.126, but I'm going to leave it as A equals 20 sine 73 because 20 sine 73 is a irrational number that I don't want to mess around with. Okay, in the third case, I'm going to take a little bit more room here, make my drawing a little more clear. I have a 73-degree angle, my side length 20, and I'd like A to be, if you don't mind, I'm just going to mark 70. I'm just not going to mark 73. I know you're going to know that that's 73, but for the sake of the picture, I'd like side A to be long enough to reach over here and over there. Okay, so remembering that this height right here is 20 sine 73, but I need not to be as long as 20. So I need to be between, so A has to be between 20 sine 73 and 20. Okay, so that means any number for A, any side length A between 19.126 roughly and 20 will make two triangles. So for example, if A equaled 19.4, or something like that, that would create two triangles. Okay, and then finally, in our fourth case, okay, I want to create one triangle because A is so long that it extends beyond. So there's my 73-degree angle. There's 20, and then side length A is much longer than 20, and it makes only one triangle. So in this case, we have A bigger than 20, and so any size number bigger than 20. So if A equaled, say, 36, then I would have one triangle. Okay, does that make sense? And I think that case 1 is very easy. Your work ends at case 1. Right after you figure out that A is too short, your work is done. You say 0 triangles. Case 2, I think, is pretty straightforward also. You just need to do a little right triangle trigonometry to figure out the values of A, of the other two angles, one of which is 90, and then the other side length. I think that's pretty straightforward. Case 3 is the tricky one. I'd like to go through an example of that one. And I think case 4 is also a little tricky because it requires the use of the law of sines and cosines. So let's do an example. Let's just finish these problems right here, and we'll go from there. So this is case 3, where we had A equals 73 degrees, B equaled 20, and then we chose side A to be 19.4. And we knew that two triangles were going to emerge from this. So let's take a look at those. Let's figure out the side lengths and everything else missing from those. Okay, so here's my horizontal. Make this picture a little bigger. Here's my 73-degree angle. Here's side length 20. And I've got two triangles here. I've got one that looks like this. This is 19.4. And I'll draw this one over here, 73, 20, and I've got 19.4 here. So I have to treat these triangles separately. But one thing we proved before was that this angle here and this angle here are supplementary angles. That helps. The rest of the work is just left to the law of sines. So let's work on it. Okay, so if we set up the law of sines like this, if we say the sine of 73 over 19.4 is equal to the sine, let's call this angle B. We'll call this one angle B prime. The sine of angle B over 20. The question is, I would set up these two triangles the same way. I mean, I could work on this one too. Sine of 73 over 19.4 is equal to the sine of B prime over 20. So let's just keep going. I get the sine of B is equal to 20 over 19.4 times the sine of 73, and the sine of B prime is equal to 20 over 19.4 sine of 73. And if I solved for B, I would get the inverse sine of 20 over 19.4 times the sine of 73. Okay, so that number in there, when I take the inverse sine of it, should give me angle B, but also it should give me B prime, shouldn't it? 20 over 19.4 times the sine of 73. So now we're thinking, if I take the inverse, if I type this into my calculator, and I take the inverse sine of these quantities, I should get two different angles? That's not possible. And this takes us back to a very important point about the inverse sine function. If you can remember, the domain and range of the inverse sine function are fixed and limited so the function can be a function. Okay, if you can remember that the range of the inverse sine function, so the sine function produces angles in the first quadrant and the fourth quadrant, as negative angles in the fourth quadrant, and obviously acute angles in the first quadrant. So in that vein, you should not expect the inverse sine function to produce b prime for you because it's an obtuse angle. It would be in the second quadrant, and this b over here should produce, sorry, this is the first quadrant angle, and that's the one that the inverse sine function is going to produce. So while both of these statements are true, the inverse sine function cannot produce b prime. Okay, so this is an important part I think students get tripped up on. The inverse sine function can only produce acute angles. So if you're looking at these two triangles, you should expect to get the inverse sine function to produce this angle B. Okay, so that's what I'm going to do. I'm going to type that in. Let's do inverse sine of 20 divided by 19.4 times the sine of 73. And you're going to see I'm going to get an acute angle out of this. 80.36 degrees. That can't possibly be B prime. Okay, so before I go any further, I'm just gonna scratch this off. It's just not gonna happen. Okay, so B is approximately, what was the number again? 80.361. 80.361 degrees. And what I'm going to do, because I'm going to need this angle later, I'm just going to store it alpha B. So stow alpha B. If you're not familiar with the stow button, I have a video on that. You can go check it out. But I'm going to store all this so I don't have to round it too early, and I can capture all the accuracy that the calculator has. Okay, so while I'm here, I am going to figure out B prime, because I know that angle B and angle B prime are supplements, so angle B prime is 180 minus angle B. Okay, and then I could go back to my calculator, and I can do 180 minus alpha B. And I got 99.640. 99.640 degrees. Okay, so I've got angle B here and angle B prime over here. That enables me to find this other angle up here, which I'm going to call angle C. Okay, so when I do that real fast, I'm going to write down over here that angle C is equal to 180 minus 73 minus B, because I know that the three angles have to add up to be 180 degrees. So that's a quick little computation. I have 180 minus 73 minus alpha B, and I get 26.639. 26.639 degrees. Just check and make sure that's right. Yeah, okay, that's good. And then over here, this angle, this little guy up here, this is what I'm going to call that C prime. Okay, that's going to be angle C prime is equal to 180 minus 73 minus B prime. Okay, I forgot to store B prime. That's okay. So I'll type it in again. 180 minus alpha B. That's my 99.640. I'm just going to store that as, I need a new letter, so I'll call it D. And I can do 180 minus 73 minus B prime, which I call D. And we're left with a very small angle. This is 7.361. Okay, so that's good. Now the only things that are missing are this side length down here, which I'm calling C, and this side length down here, which is C prime. I apologize, my C's, you can't tell the difference between lowercase and uppercase, but the angle is uppercase and the side length is a lowercase. So how do I go about finding side length C? Well, I use the law of sines again. Okay, so I can use any angle, any side, but I need to have the side C figured out. So I'm going to write it as sine C. Even though I know the angle, I'm still going to use the letter because I just don't feel like writing all those digits down. Actually, I'm going to do C, the unknown side length, over sine c, and I do that because I want my unknown quantity in the numerator, and I can pick any other of the two pairs. I'll pick the given information, which was 19.4 over the sine of 73. Okay, and so now I have to solve for c. C is equal to 19.4 times the sine of c over sine of 73. Now this is a lowercase c standing for the side length, and this is an uppercase c standing for the angle c. So here I go. 19.4 times the sine of angle c. I didn't store it. Okay, I'll just type it in as 20. You know what I'm going to do? I'm just going to store this real fast because I like to use a stow button. I'm stick to my principles here. Okay, I'm going to store that as angle C. Okay, so let's try this again. 19.4 times the sine of angle C divided by the sine of 73. Okay, that's 9.096. Okay, and I go back to my picture and I make sure that that side length makes sense. Does that make sense to be 9? Sure, that's an acceptable number, roughly 9. Okay, that's good. And then C prime over here is going to follow the similar pattern. So side length C prime over the sine of C prime, angle C prime, should also equal, now I've got 19.4 or the sine of 73. So side length C prime is equal to 19.4 times the sine of angle C prime all over sine of 73. Okay, and my I have to also store C prime quickly, so that's what I'll do here. I've got 180 minus 73 minus B prime, which I stored as D. Okay, make sure that's right. Okay, I'm just going to store that as E. Okay, now I can do 19.4 sine of C prime, which I just stored as as E. Yep, over the sine of 73. Oh, forgot to put the division symbol in there. Okay, I just inserted a division symbol, so there we go. That looks right. So then I get this side length is approximately equal to 2.599. Okay, and I go back into my picture and I say, does that make sense to be 2.5? Yes, it should be shorter than 9 over here because it's squished in angle. The angle appears smaller, so the side length down here should be smaller. Okay, now I have all three missing parts. I was given 3 things, and the triangles have 6 parts. It's 3 sides, 3 angles, and I found 3 missing parts for the triangles, and they are here, here, and here for this triangle, and then here, here, and here for the other triangle. Okay, and as promised, we're going to finish the case 4 example that we had from above. So I believe the numbers were the angle A was 73 degrees, the side B was 20, and then we chose A to be really long, and the number was 36. Okay, so we've got this picture. We've got a 73-degree angle here, a side length of 20, and we've got a really long side over here. And before I go on, I want to make sure you understand, when you're given an angle and its opposite side, any other side is going to create an SSA situation. Okay, so what you're looking for to identify SSA, two sides and an angle, obviously, but two sides and an angle could be SAS. But notice if you have SAS, you can't have an angle and its opposite side, because the angle is included between the two sides that are given. So the key what prompts students to recognize that we've got SSA is that you've got an angle, its opposite side, and then some other side. And you're always going to be able to draw a picture like this. Okay, so we need to figure out this angle, and this side. So I'm going to call this angle B because it's opposite side B. This is angle A, and this is side A. Sorry, not true. This is angle C, and this is side C. Okay, so how do I go about doing this? Well, I have enough information to figure out angle B with the law of sines. So here we go. Sine of angle B over 20 should equal the sine of 73 over 36. So therefore sine of B is equal to 20 sine 73 over 36. And so the B is equal to the inverse sine of 20 sine 73 over 36. And I know I could simplify that fraction, but doesn't help me if I'm typing into a calculator. So inverse sine of 20 sine 73 divided by 36. This is roughly 32.092 degrees. And then side angle C is equal to 180 minus 73 minus B. I can find that out right now. If I store this as B, notice that B used to have something else in it. Now it's occupied by this. Okay, so 180 minus 73 minus B. And again, I'm using this stored version of B so I get all the accuracy I can get out of my calculator. There's no such thing as sig figs here because there's no measurements. That number is 74.908. 74.908 degrees. And then I can figure out side C by doing another law of sines with the other information. So I can say here that we have C over sine C should equal 36 over sine 73. I know I know angle C. I'm still writing it as a letter, but I just don't feel like writing down all those numbers. So side C is equal to 36 sine C over sine 73. Okay, and all I need to do is store angle C right there. So store angle C, alpha C, and I should be able to type this one in right quick. 36 sine alpha C divided by sine 73. And that should give me the side length C, 36.346. Now, does that number make sense? Should it be longer than 36? Do we like that length, 36.346? I sure do. Definitely want it to be longer than 36 because this 20 at a steep angle there, it isn't giving me much horizontal length here, but it's giving me enough, 3.346. Okay, so I've got the three missing parts. I've got angle B, angle C, and side C right there. Okay, so I think that covers not only just the ambiguous case, but also just how to solve parts of triangles and how to recognize what parts are given. Hope that helps.